Nuclear Physics Class 9, in which we are going to study two accelerators. Accelerators in the sense the positive or negative ion which is emitted is accelerated, whose velocity is increased to a desired level. So how to increase the velocity of that ion? That is done by using an accelerator. So we are going to study two accelerators, linear accelerator, first one, and the second one is, that is, cyclotron. Okay, so therefore let us study one by one. So basically this is the block diagram of linear accelerator. Along it, the axis of the tube, we are going to increase the velocity of the ion. So that is called linear. Okay, and accelerator increase in velocity. So the basic diagram of the linear accelerator is as shown in figure. It consists of these drift tubes. So this is coaxial hollow metal cylinders. So these are also called drift tubes. These are connected to the high frequency radio frequency generators. Okay, so now frequency generator in the sense the AC cycle, in which there is a positive half and negative half cycle. Okay, so now here alternate cylinders are connected to, in the sense 1, 3, 5, 7. So these cylinders are connected to one terminal, and 2, 4, 6, 8 are connected to another terminal. Okay, so when, suppose how the ions are accelerated, here is the element which emits the ion. Suppose a positive ion is emitted from this element, then it is moved towards this first cylinder. If it is a positive ion, it should be dragged by this cylinder. When only if it is negatively charged. So therefore, when the AC is applied at the initial stage, this tube is negatively charged because the negative half cycle of AC is connected. So the positive ion is accelerated towards this. As soon as it enters into this coaxial cylinder, then this becomes the positive and it moves out. Then alternately, when it was negative, the coaxial cylinder first one is negative, that time 2 is positive. But as soon as the ion exits from this first drift tube, it becomes positive and this tube becomes negative. So therefore, in between these two tubes, the first tube is positive, which pushes the positive ion, and the second tube is negative, which drag the ion in between these two cylinders. The ion is accelerated. So again it enter into the tube 2, and as soon as it exits from the tube 2, that time the tube 2 becomes positively charged and the tube 3 becomes negatively charged. So the cycle of the radio frequency oscillator is so adjusted that as soon as the electron exits from one tube, it becomes positive and the next tube becomes negative. So in this way, the electron or the ion is accelerated between these two gaps, and finally it acquires desired velocity or acceleration. So this is the basic function of linear accelerator, dear students. The schematic diagram of linear accelerator is as shown in figure. It consists of a coaxial hollow metal cylinders or drift tubes 1, 2, 3 and 4, etc. They are linearly arranged in a glass vacuum chamber. The alternate cylinders are connected together, the odd numbered cylinder being joined to one terminal and even numbered ones to the second terminal of the high frequency generator. Thus, in one half cycle, if tube 1 and 3 are positive, 2 and 4 will be negative. So after a half cycle, the polarities are reversed. The ions are accelerated only in the gap between the tubes here, where they are acted upon by electric field present in the gap. Okay, so suppose a positive ion leaves A aperture and is accelerated during the half cycle when the grip tube 1 is negative with respect to A. The length of the tube 1 is so adjusted that the positive ion comes out of it. The tube has positive potential and the next tube 2 has the negative potential, just we have discussed earlier. That is, the polar potentials changes sign. So in this way, the acceleration of the ion takes place in linear accelerator. Then what are the limitations? The length of the accelerator is conveniently large and it is difficult to maintain vacuum in a large chamber. So here the linear accelerator length is very much high. So in that length, in order to maintain the vacuum in that chamber, it is very difficult. The ions current in the form of short interval impulse because the ions are injected at an appropriate moment. Okay, so these are the limitations. So if you find any difficulty, you just ring me on my number or you contact me in the department. Okay, so let us study the next one is cyclotron. So here the ion is accelerated linearly and in cyclotron the ion is accelerated in a circular path, that is spiral path we can say. Okay, so how basically this cyclotron works? Let us see. So you can see there are two D's, D1 and D2. In the sense, the shape of this hollow semicircular disc is looking like a D shape, and this is the half semicircular, that is second D shape. So this is the D1 and this is the D2. These D1 and D2 are connected to the high radio frequency oscillator here, and this both D's are kept in an evacuated chamber, vacuum chamber. Okay, and then these two are applied with the, that is strong magnetic field from the electromagnet. Okay, these two are the two strong magnetic magnets which apply the magnetic field to these D's. So you can see in what way these magnetic lines of forces are moving from north to south perpendicular to this surface. Okay, so what is the purpose of these magnetic discs here? So you all know that whenever a charged particle enter into the magnetic field, it makes a circular motion. Okay, so that is a circular path, it starts moving. So that thing you already studied. Okay, so that is the principle we are using here in order to move the charged particle in a circular path. Now here also, dear students, the ion is get accelerated between these two D's gap. So here it is a gap. Okay, so in this gap only the ion is accelerated. Whenever it enter into the D's or this D, it doesn't accelerate it. It just moves inside the D, but acceleration takes place in between these two D's gap. Okay, so now, so how it works? Suppose the ion is ejected from the center of this D, then it moves with some velocity, initial velocity. So when it exits from this source, these D's are applied with the electromagnet. So therefore it makes a circular path. So these two D's are connected to the, again, the high frequency radio frequency oscillator. So now the frequency oscillator is so adjusted that, so if the D1 is positive, then D2 is negative. When D2 is negative, D2 is positive, D1 is negative. In the sense, in the cycle of alternating current, these two D's are applied and they are changing always. Okay, so now when the particle is emitted, then if suppose it is a positive ion, then D2 is negative. In this gap, it is attracted towards the D2 and due to applied magnetic field it makes a circular motion. So again, after making a circular motion, it enter into the D1. At that time, that is, D2 changes positive and D1 changes negative polarity. So therefore, it is attracted towards the D1 and repelled by the D2 in this gap. Okay. So again, it makes a circular motion and it exits from the D1. That time, D1 becomes positive, D2 becomes negative, and D1D repel it due to positive charge, and D2 is the negatively charged, it attract towards the D2. So it again makes a circular. So here the particle is describing every time it enter into the gap, it get accelerated, and that time it makes a, that is, greater radius. It moves in a greater radius. So the particle is accelerated in this semicircular path and finally it exits from this direction with a greater velocity or desired acceleration. Okay, so this is the basic working of cyclotron. So let us see the construction. The cyclotron consists of two hollow semicircular metal boxes D1 and D2 called Ds. A source of ion is located near the midpoint of the gap between the Ds at this point. The Ds are insulated, these two Ds are insulated from each other and are enclosed in another vacuum chamber. The Ds are connected to a powerful radio frequency oscillator. Here it is a radio frequency oscillator. The whole apparatus is placed between the pole pieces of a strong magnet. So this is the D1 and D2 are placed between these two strong magnets. The magnetic field is perpendicular to the plane of the Ds. So if this is the plane of the D, then the magnetic field is perpendicular to the plane of the Ds. Okay. So then here is, suppose the positive ion leaves the ion source at the center of the chamber. At that instant, when the Ds, D1 and D2 are at the maximum negative and positive AC potential. In the sense, D1 is at negative and D2 is at positive potential, respectively. The positive ion will be accelerated towards the negative D1 before entering it. The ions enter the space inside the D with a velocity V is given by VE is equal to half m V square, where V is the applied voltage and E and m are the charge and mass of the ion. When the ion is inside the D, it is not accelerated. When it is inside this D, it is not accelerated. We have already talked about this. When the ion is inside the D, it is not accelerated. Hence, this space is called field-free space. Okay. Inside the D, under the action of applied magnetic field, the ion travels in a circular path of radius r. Is given by. We all know that is whenever a charged particle initial movement enter into the magnetic field, it starts moving. It is experiencing a force. That is dEV. D is the strength of the magnetic field, E is the charge, and V is the velocity. That it is equal to mv square divided by dE. Okay. Now dEV is equal to mv square divided by R. It should be R here. So therefore, where V is the flux density of magnetic field, therefore, R is equal to, just rearrange these terms, R is equal to m into V divided by dE, 1 V get cancelled. Call this equation number 2. Therefore, the angular velocity is given by omega is equal to V divided by T, that it is equal to. So here V divided by R it is, that it is equal to, substitute the value of R from the above equation, it becomes dE divided by m. and time taken by the ion to travel the semicircle, that semicircle T is equal to pi divided by omega, that it is equal to, substitute the value of omega from this equation in this equation. So it becomes pi into m divided by v into e. Call this equation number 4. Suppose the strength of the field B or the frequency of the oscillation F are so adjusted that by the time the ion has described the semicircular path and just enters the space between D1 and D2, D2 has become negative with respect to D1. The ion is then accelerated towards D2 and enters the space inside it with a greater velocity. It will describe a semicircle of greater radius in the second D. But from the equation T is equal to pi m divided by dE, it is clear that the time taken by the ion to describe the semicircle is independent of both the radius of the path r and the velocity of the ion v. Hence, the ion describes all semicircles wherever be their radii in exactly the same time. This process continues until the ion reaches the periphery of the things. Periphery in the sense at the border of these things. The ion thus spirals around in circles of increasing radius and acquires high energy. The ion finally comes out of the bees in the direction indicated through the wind. Okay? So its limitations, the energy of the ion produced by the cyclotron is limited. In the sense, we cannot make high energy ions in the cyclotron. Clear? If you find any difficulty about this cyclotron, you can just call me or you can meet me in the department. So energy of the ion, that is the last point of this chapter. So here let r maximum be the radius of the outermost orbit described by the ion and v maximum be the maximum velocity gained by the ion in its final orbit. Then the equation for motion of the ion in magnetic field is given by V max is equal to m v square max divided by r maximum. So V maximum is equal to B E divided by m into r maximum. The energy of the ion E is equal to half m v square maximum. We all know. Just substitute the value of V maximum in this expression. So it becomes V square r square maxima divided by 2 into E square divided by m. The condition for acceleration of ion in the entire d gap is pi m divided by dE is equal to T by 2 or T is equal to 2 pi m divided by D. Okay. So the frequency of the oscillation is F is equal to BE divided by 2 pi m, just T is equal to 1 by F or F is equal to 1 by T. Substitute here, it becomes reciprocal. So hence the energy of the ion is given by E is equal to 2 pi square r square max F square into m. Just substitute in this expression and this expression, we will get energy is equal to 2 pi square r square maximum F square divided by m. Okay. So here completes nuclear physics. Okay. So if you find any difficulty about this chapter, you just meet me in the lecture. Thank you, dear students. All the best.